Okay, so this question is add a distance. So you're given two strings, word1 and word2. So you want to do some operation to insert a character, delete a character, and replace a character. So you have to return the minimum number of operations required to convert word1 to word2. So in this video, I'm going to talk about two solutions. One is using the DP, the other one is using the recursion. Alright, so just briefly talk about the example one. So I want to it's either like word1 convert to word2, or either word2 convert to word1, something like this, right? So again, like there are definitely many solutions, but in this one I'm going to talk about like the DP first. So this type of question is definitely a standard DP, and then basically like you want to make the default. So imagine like you put the word1 for the row and word2 for the column. So just basically make the default value. So imagine that every single word doesn't match. So I'm going to say A and A for the word1, and then you know, C, D, E, F, G, you know, for the word2, right? If every single word doesn't match, right? You either what? You either add the number of the missing character, you know, or you replace, right? So you either delete or you insert, right? They are the same procedure. So so imagine here, so they are not the same, H and R are not the same, so they can either replace, right? And then R and, you know, O are not the same, you have to insert, right? And then your HOR and R, they are the same, right? So if they are the same, you want to remain what? You want to remain 2, because you only need to either add 2 words to compare with this one, right? And again, this is S, so you want to insert again, you know, and then E again, so basically it's like it. So there are definitely a pattern. So what's the pattern? I'm going to just talk about pattern. So if the words are matched, if chart AI is equal to chart AI, chart J, sorry, I represent the word1, J represent the word2, right? If they are the same, right, you want to just take a diagonal, which is what? Imagine this is the table. If you're at the current spot, you just take a diagonal value and then just put it right here, because you know the current position for this ladder are the same, so you don't have to either insert, delete, or replace. So this is the trick. And then what if they are not the same? If they are not the same, you want to do the insert, delete, or replace, right? So just look at this. So A, B, right? So you want to know, you can if at this current position, you want to know you can access here, you want to know you can access here, you want to know you can access here as well. So find out the minimum on your neighbor and then +1, because you want to do the operation, so you need to +1. So find out the minimum operation of minimum number and then +1 for your current position DP, and this is the trick. So this is straightforward enough. And also in the beginning of the video, I talk about like there's a default value, you know, something like this. Do I have it? If not, then I'm gonna talk about. So imagine your the string 2 is XYZ, and then your string 1 is ABC. So ABCDE, and then you know like they are definitely not matched, right? So if they are not matched, you know, you are going to change every single word, or you either delete, insert, replace, doesn't matter, change every single word, right? So the default value for column 0 and then the row 0, you are going to just set by the like the length of the current position number, right? And then if they are not the same, just find out the minimum. So I'm going to just talk about this. So if they are not the same, find out the minimum of 3 neighbor plus 1. So 0 plus 1, 1, right? And then B, find out the minimum. And then this is 1, 1 plus 1, 2. Find out the minimum, 2, 3, minimum 3, 4, and then minimum 4, and then plus 1, 5. And then you do exactly the same thing, and then you end up what? You want to replace 3 characters, right? And you want to return this. Alright, so this is the DP solution. And let's start coding. So I'm going to have db and a new int, and then war1.length plus 1. You want to store the default value, right? Alright, so for the default value is pretty straightforward. So you want to set the column and the row, just set by the index, and this is going to be exactly the same thing. dp0j equal to j, right? So now we have it, right? Then we can traverse from the position starting from 1 in the dp. So war1 length, and then j for war2 length. So straightforward enough if they are the same. So since I starting the index at I equal to 1, and if I want to say war1.chart add, I need to subtract by 1, right? And then war2.chart add j minus 1. If they are the same, the current dp ij will be equal to dp I minus 1 j minus 1. Alright. So what if they are not the same, right? It's still going to be ij, but if you want to find out the neighbor is going to be what? The minimum between the. So I'm going to have a function called minimum, so probably int min, and I'm going to pass in the 3 value, and then it's going to be return max.min a max.min b c. So it's going to be minimum between the neighbor. It's going to be I minus 1 j dp I j minus 1 dp I minus 1 j minus 1. Alright, once you know it, then you will return dp at the word1.length and then word2.length. So this is the trick. And then let me submit. dp, there should be a typo, dp, right? dp. Okay, so I have a mistake because I forgot to plus 1, right? So in this, this is the mistake for sure. So if they are the same, you don't worry about it. You just take a diagonal value, which is going to be like minimum. And then if they are not the same, you want to use the operation. So imagine this is insert, this is delete, this is replace, right? And then once you have it, you want to find out, you want to add 1 by your operation number, and then submit. Alright, so for the time and space is pretty straightforward. This is a space, all of m times n. M can be m represent war1, n represent war2, right? And this is all of m, this is all of n, and this is all of m times n as well for the time, right? So time and space are straightforward, it's like all of nn, all of nn, like they are the same. Time and space are the same. So let's talk about the recursion solution. So the idea is going to be the same, right? So what you have to do is what? You want to still going to create a DP, but in this time you are traversing from the bottom right to the top left, and then like storing the DP using the same same method on recursion solution is the same idea. So let me just start coding. So I have an integer 2D array. I'm going to call DP. So the reason why I'm using the integer instead of int is because when you want to traverse the position using the recursion, and if the value is a number, it doesn't matter if it's 0 or -1, it will definitely affect your answer. So you want to set equal to null. So again, the size is going to be word1.length +1, word2.length +1, and then I just have to traverse, right? And word1, word2, and the length is word1.length, word2.length. So this represents the index. So public int traverse string word1 string word2, and int I represent word1, int j represent word2, right? Okay, cool. So so I started from the end, right? So I will traverse all the way to 0, 0, right? So if I equal to 0, then I will just return j. So I will definitely know like what are the current position, right? And then if j is equal to 0, then I will return I. Okay, cool. So I'm just keep updating for my current traverse position, and you can say recursion over here, but I will say traverse. Alright, so for every single time we need to find out the current, the value that we have been used. So I just say if dpij does not equal to null, then I just return dpij, and then I need to find out if they are the same for the current chart. So if word1 chart at I equal to word2 chart at j, I don't have to worry about this, right? So I just have to re-traverse the word1, word2, and then I-1, j-1. Just keep going on the previous character, right? And then else. So we can put else over here, but this is pretty, irrelevant because I return over here, so I will just, just keep writing. So now the same. The same. Okay. So I will say int. I have 3 operations, right? So insert equal to what? Traverse word1, word2, I j-1, and then delete word1, word2, I-1 j, and then last replace traverse word1, word2, I-1, j-1. Alright, you might be wondering that why do I pick insert for j-1, delete for I-1, replace for I-1, j-1. This is actually doesn't matter, but imagine that you want to insert the word1 to word2, right? And then you will say j-1. And then if you want to delete, you cannot using the same index. You already delete the j-1, and then you already insert the j-1, right? You use the operation, and then if you want to use the delete operation again on the same position, this is not allowed. So just just a trick, right? So we have to find out the minimum, right? So the minimum is going to be max.min insert max.min delete, and then comma, and then replace, right? So once we find out the min, right, we need to +1, don't forget, right? We use the operation, right? So we need to store into the dp, so dp I j equal to min, and then you will return min or dpij, doesn't matter which one you use. But do I have missed anything? No, right? So let me run it. Oh, new integer, sorry. And that would be it, right? Oh, okay. So this is the trick again. So I started with 1.len, so that will be out of bound for sure. So you want to use the -1. You're starting from the last one, the last character, which the index starting from 0, right? So it's gonna be I-1, J-1. Right. So for time and space, they are the same. It doesn't matter like how many traverse you go over, because we will stop at the position if they are not a node. So if you get rid of this one, right, and then you keep traversing, and maybe you don't have DP, right, and then you will just keep traversing. That will be three iteration, keep going over. So you have the 3 to the power of n, right? 3 to the power of n. Doesn't matter which one, n or m. If one of them is the longer, then you will pick the worst case 3 to the power of n, right? But in this one, we talk about this. So for the time and space for the current solution, it's going to be all of n times n, right? And then this is the space, and the time is going to be the same. You traverse every single position once, and then the time and space is going to be all of n times n. Alright, so if you still have a question, leave a comment below, subscribe if you want it, and I'll see you later. Bye.